And just to introduce two just quick little terms to you, specifically they're going to talk about in section 3 of chapter 4 is the whole term of an amortization schedule. And all that is just a printout of exactly how much you would have to pay every single month or however many quarters or however whatever you've just the loan has set up with you, whether it's going to be monthly or quarterly. But it's just a printout of basically what you would have to do over the whole entire life of the loan in order to pay it off. And that's an amortization schedule. And then what a sinking fund is just a specific account that's set up where you're going to need so much money due. Like I say here, a parent saving $50,000 for a child's education, or for a company when they know that, okay, I know I want to replace all the computers in a matter of 5 years, and it's probably going to estimate at a cost of $100,000 for us to replace all of them. How much do we need to set aside now in order to get that to happen? And that's just a sinking fund. Okay, it's setting aside money now for basically it's just I consider a sinking fund as you're losing the money no matter what. It's not like you're making payments to eventually save. It's just like you're making these payments because you're going to have a lump sum that you're going to have to give away because you're buying computers. It's when you make that payment, the money's going to be gone no matter what. So, okay. And also it's to the benefit of the employer though, too, and the parents too when they're saving for college or saving for like computers, because if they start doing it now, remember they get to earn that interest just like that lottery commission does. So that way if computers are going to be $100,000, they don't have to spend $100,000 right now. They can just start saving, let's say even $770,000 because they know that that's going to grow, through the life of the loan. Okay? All right, so let's look here at example 8. We want to find the size of the payment, so this time we're wanting to find payments. Everything in section 2 we are finding future value and present value. Now we're actually finding the payment size. And they give us information, but again we're going to use the exact same TVM solver to do all the work for us. Okay, so we want to find the size of the payment. This is what we're going to be asked to find right there. We want to require to pay off a $16,000 in 4 years. Oops, hold on, I wrote that. Put the question mark in the wrong place. I was not used to it being right there. Okay, the payment is what we're asked to find. The present value is $16,000 because we're looking to pay this off. Okay, so when you pay it off, obviously the future balance is 0. We're going to do it in 4 years at 9% compounded monthly. So the compounds per year is 12, or the payments per year obviously is still going to be 12. And we want to pay it off in a total of 4 years. Okay, so if we go to our calculators and have it do the work for us, you should get a payment value of, looks like $398.16. You see how your calculator makes it negative already for you because it's showing you you're going to have to give this money away. Okay, so hopefully this makes just a little bit of sense. Let's go on to example 9. We want to find the payment size required so that $250,000 is saved after 25 years at 10.5% compounded monthly. So entering in the information as we kind of go through it, we want to find the size of the payment. It's required so that $250 is saved. So that's what we're hoping to, we're paying ourselves money to have $250 available. So that's going to be our future value is the $250,000. And we want it saved after 25 years, compounded monthly. Okay, so we're making 12 payments for 25 years at 10.5, so I'm going to put 10.5. And the number of payments per year or compounds per year are both 12. So we're going to make monthly payments. And so we want to know, obviously the present value, since we're looking to save $250,000, then the present value is 0. We're starting at a 0 balance, and we actually want to build up to where that final balance is $250,000. Okay, and we use our calculators to help us out here. Then we're going to have a payment of $172.95. That's not really that bad. I mean, truthfully, just to have to pay basically $172, $173 just every month. I mean, a lot of us can actually pay $173. Granted, it's going to take 25 years for this to accumulate, but to have $250,000 after 25 years, hey, I think I could try it. Wouldn't hurt to try, right? Okay, so now let's do some book work. And I hope all of you guys are practicing this in your calculator. That's the easiest way. Don't just sit here and watch me do it. Actually work on this together, because this is what we would normally be doing in the classroom anyways. And this is fun. I mean, hopefully this is kind of fun and easy just to play around with money and numbers. And so hopefully you're enjoying this. But all right, let's look at number 17 on page 222. Well, as we read through this information, let's assign values. Okay, so number 17, suppose payments are going to be made for 6.5 years. So we're going to be making them for 6.5 years. Okay, we'll decide how much, and they're made at the end of each semi-annual period. So semi-annual is twice. And you know that whole thing right there where it says it's going to be made at the end? That's the part where you make sure your calculator has that very bottom of your screen has end highlighted. That's all that means. Okay. You're going to make it into an ordinary annuity, earning interest at the rate of 7.5%, so 7.5%. And if the present value of the annuity is $35,000, so $35,000, we're going to find payment. We just want to know what the size of each payment should be. Okay, so to finish this up, the number of payments per year, the number of compounds per year, it said semi-annually, so it's 2. And it looks like you have the present value of $35,000. So obviously this is more of like a loan. You want to know the payments in order to pay it off. So the future value is going to be 0. All right, let's use our calculators one more time and see what we can get for payment size. When I put this into my calculator, I get a payment of $3,450.87. So definitely a much higher payment, but when you think about it, you're paying $35,000 off in just 6.5 years. That's a pretty aggressive payment, okay? Now I want you guys to do one thing. Just as a side note, I want you to take that $3,450.87, so the amount of payments, and I want you to multiply by however many total payments we're making, which is that 6.5 times 2, okay? So I want you to multiply it by 13. And when you do that, what comes out is $44,861.31. Okay, so what does this number represent? Just think about it for a second. Well, and this is the total amount of money that you're having to pay out of your pocket, because you're making these payments, 13 of them. So this is really what you're paying. But the balance of the loan was just $35,000. Well, that's that whole part of when you go to actually make a payment, like when you're making your mortgage payment, it's not just dollar for dollar. When you pay them $1,000, your balance doesn't go down $1,000, but you have that whole interest involved in there. So that's what this part is showing you right here, is the whole, you have the interest. So if we take that number and subtract off 35,000, which was the actual true number, then you're basically paying roughly, let's write it like this so y'all can see this. Your interest you're having to pay on that loan is $9,861.31. Okay, so it's almost like that kind of out of $35,000, you're still having to pay almost $10,000 more in just interest alone. So that is showing you how much interest can kill you. If you ever have a loan, one of the easiest things you can do, especially one way up there at 7.5%, is pay it off. I mean, you've got credit cards that can be up to 10 to 15 to 20%. And the worst thing you can do is keep money on those things. You have got to pay them off, because look, in just 6.5 years, this person gained basically $10,000 in interest. That's extra money they have to pay. It's just crazy. So you definitely, if you ever have a loan, you want to pay that off as soon as possible. Okay, let's go to example number 11, which is 23 in the book. And if we look at this part, it's 23 has part A and we have part B. So part A, it's all about financing a car. So we have the price of a new car is $16,000, and you're going to make a down payment of 25% off of that. And then you're going to get a loan for the remaining balance at a rate of 10% per year, compounded monthly. So the interest rate is going to be 10%. It's compounded monthly. So, and it looks like in part A, we want to know the monthly payments. So it's going to be the monthly payments to make if the car is financed over a period of 36 months or over 48 months. Okay, so since they actually kind of did the math for us right there, we're going to look at it in then two pieces. Okay, we're going to look at once when it's 36, and then we're going to look at it again where it is, let me change colors, and then again when it's 48. Okay, so obviously we're looking at a loan, and no matter what, the future value of any loan, especially when you're doing the car, is going to be 0. The payment we're going to look to find, and we want to know the present value of that car. Okay, well, let's talk about this present value for just a second. Okay, and remember, the present value, I should say, not really it's of the car, it's of your loan. The car itself was $16,000, but we don't need a loan for $16,000 because we made a 25% down payment. So we want to subtract off 25% of, multiply, so of the value of the car. So then hopefully, obviously, a quarter, by the time we pull off a quarter of the car, what's going to be left then is $12,000. So that's what you're going to be taking the loan off on, is just $12,000. We don't need the loan on $16,000. We need the loan on $12,000. So hopefully I hope y'all are listening in the sense of whenever you're typing in your calculator, that's always about with respect to the loan amount, what you need to ask the bank for, okay? All right, so let's do this twice. We're going to do it once where we're looking to pay this car off in 36 months, and then again we're going to look for it when we're wanting to pay it off in 48 months. And so let's get those two values and compare our answers. Okay, so when we look at 36-month one, the total payments are $387. If we look at a 48-month loan, then the payments just go down roughly by $83, okay, to just $304. So that's part A. Now part B wants us to find then how much we're paying in interest. So it's kind of like that last thing I talked to you guys about. Let's look at the two different interests. So the interest when you're doing at 36 months, okay, that's basically going to be the total, what we're paying. So it's the $387.21. We're going to pay 36 payments of that. So that's going to tell us how much we're actually paying to the bank. And then if we want to subtract off the loan amount, which is $12,000, we're going to get an interest of $1,939.56 for that one. Okay, so now if we go over and we look at, well, this time we want to extend it one more year. We don't want to pay it off, the car off, in just 3 years. We want to pay off in 4 years. So what does this do to our interest? So we want to take $304, multiply it by the 48 payments that we're going to make. Just a second, let me get this looking prettier for you. And then we'll subtract off the initial amount of the loan, which was $12,000. And with this one, then what we're having to pay in interest is $2,608.80. So, you know, car dealerships are going to appeal to you because they're going to sit there and go, hey, you know, you could pay this off in 3 years, but if you pay it off in 4, then you only have to, you know, you get a basically, you don't have to worry about $80 a month on your balance, which you have to pay to the bank. So like, hey, why don't you just go with those 4 years? Well, look what's happening. They're almost getting another $700 in just free money for them and just interest because you decided to go that 4th year. So it's just like, do you want to pay the money or do you want to keep that money? Okay, so again, it's just what this is showing you. It's just easier for you in the long run if you just be more aggressive with your paying off of any kind of balance. Okay. All right, so went a little too far. Let's go back to example number 12.